All right, so we just talked about, continuing section 5.2, we were just talking about Venn diagrams on page 10. And now we're going to use some Venn diagrams to help us answer some probability questions. Example, smartphones and tablets. Study found that 57% of students have smartphones and 30% have tablets and 18% have both. Find the probability that a randomly selected student has a smartphone or a tablet. So, I don't know. Every time I come across a probability question, I ask myself one question. Uh, or I go through a series of questions, perhaps, whatever. Basically, I say, can I do this question intuitively, or will it be easier to do, like, using formulas or a Venn diagram or a tree diagram, which we're going to learn a little bit later. And for me, when I see this and this and this, and I want to calculate the probability that someone has a smartphone or a tablet, it doesn't really click with me automatically. Maybe with, you guys are probably brighter than me. Maybe for you it will. So I need to organize my information. So I'm going to go to a Venn diagram. I basically have two groups of people. This is smartphones and this is tablets. So let's put in these percentages. So 18% have both. This is 18%. However, the most common mistake people probably do on this is they put 57 here. Well, this is not 57. This 18 is part of the 57. So in this space, I need to put in the people that own smartphones but don't own tablets. Well, if 18% own tablets and smartphones, I need to take 18 minus that 57. And I stink at math, so I'm going to just, type it in my calculator because why not? So 0.39. If I add those up, that accounts for the 57% that have smartphones. 30% have tablets. 18% have tablets and smartphones. So if you take 30 minus 18, 12% have tablets and no smartphones. And if I wanted to complete this picture, I'd need to put something here. This would represent the person that owns neither a smartphone nor a tablet. So that would be 1 minus, well, I guess I just do this. Well, this is 30 plus this, so that's 100% minus 30 plus 39 is 69. So this represents the 41. I was just seeing if you guys were going to catch that. 31? 31% that own neither. Okay? So now let's go back to our original question. Find the probability that a randomly selected student has a smartphone. So find the probability that you have a smartphone or a tablet. Well, if I'm looking at this, I could just kind of do it conceptually. I could just take this group plus this plus this. These three things together would add up to what I want. So I could say 0.3, I could say 0.39 plus 0.18 plus 0.12. That would add up to that 69% that I just did over here. And that's just kind of using the Venn diagram and kind of using intuition. Basically, the Venn diagram breaks my events into mutually exclusive events. If I wanted to use a formula, I'd have to take the probability, let's just do another equal sign here, which is also equal to the probability you own a smartphone plus the probability you own a tablet minus the probability you own a smartphone and a tablet, which is probability you own a smartphone. So another place where people tend to make mistakes, they put this number here down. Well, no. The people that own a smartphone are these people plus these people. That's the original 57.57 plus. People that own a tablet, 18 plus 12, or this 30. Minus the probability you own both. Well, 18% own both. So this is 87 minus 0.18, which gives me that 0.69. All right, so I'm not doing this to confuse or just to add clutter, but I could use the Venn diagram and kind of some intuition to get my answer, or I could break it down and use the formula to get the answer. Just whichever way you do it, be careful. You should get the same answer. Okay? Find the probability that a randomly selected student has a tablet but not a smartphone. All right, so probability has a tablet but not a smartphone. Ugh, how do I even write that down? But no smartphone. So intuitively, I could just look at the Venn diagram and kind of put it together. Which people own a tablet but not a smartphone? Well, that's really easy. That's just the 12%. These people right here in this group represent a tablet and no smartphone. How would I do it using formulas? Well, you have to write it as an and or an or. This is a probability that you own a tablet and no smartphone. Now, as far as finding this theoretically or with formulas or whatnot, we need to figure out some formulas for ands first. But I think that what I want you to take out of this is that, even once I show you the formulas for and, this is not the way you want to do it. A Venn diagram makes it easy. Find the probability that a randomly selected student has neither a smartphone nor a tablet. So no smartphone nor tablet. That means not in any of these groups. Well, we already calculated that guy right here. I don't even have to write down the probability statement, really. If I wanted to write it down, this is a probability that somebody has no, but by the way, I'm using these little negation from geometry, has no smartphone and no tablet. Again, even when we're done with this unit, we're not going to want to use the formula to calculate this thing. This is going to be the way we want to do it. Find the probability that a randomly selected student has a smartphone or a tablet, but not both. So again, I don't even want to write the probability statement down with ands and ors. Just calculate it. Probability has a smartphone or a tablet, but not both. So that would be smartphone but no tablet, tablet but no smartphone. So it's really just the 0.39 plus the 0.12, which is 0.51. I'm really bad at arithmetic, sorry. Yeah. How would I write it? What's the probability? Has a smartphone or a tablet, but not both. Has a smartphone or tablet and oh geez, I'm not even really sure. Has a smartphone or a tablet and yeah, I don't know. I fail. Sorry. This is the answer though. This is the answer. I actually don't really want to give up on this so easily, but I also don't want to sit here and think about it for 5 minutes on the video while you're watching. So let's just forget about it. Example. Math and physics are the answer. 29% of kids got an A on a math test. 22% got an A on a physics test. 57% of students didn't get an A on either test. Okay? Good enough. What percent of kids got an A on both tests? So, can I do this intuitively? 29% got an A on the math test, 22 got an A on the physics test. By the way, some of you guys probably could have done this one here conceptually or intuitively. This one here I think is even a little bit more difficult. Well, I really don't know, so I'm going to draw a Venn diagram to organize my information. So we got two tests. We got math test and a physics test. So these blobs represent the people that got A's on those tests. So 29 got an A on the math test. So I can't really put 29 here because, I don't know what this is yet. So I can't put 29 there because that doesn't go there. But in order to figure out what goes here, it's got to be, it depends on this, right? 22 got an A on the physics test. Okay, so that's this plus this is 22. And 57 percent of students didn't get an A on either test. So that's this outside spot right here, which is a little bit strange for them to give us that. So if I knew this, I can figure out this. And if I know this, I can figure out this. And I know all four of these things add together have to equal 1. So I think I can kind of get it. It's really this piece here that is what's holding me back. So let's put a variable x in that spot because that's what I don't know. Well, if that's an x, then I know this is 29 minus x. Just kind of like I did here when this was 18. This was 57 minus 18. And if this is x, then this is 0.22 minus x. And I know 0.29 minus x plus 0.22 minus x plus 0.57 has got to equal 1.00. So these x's cancel out. So, oh gosh, 29, 22, and 57. I'm just going to add those up. 29, 22, 57. 0.108 or 1.08. 1.08 minus x equals 1.00. Let's move the x over here, 0.08. So apparently this is 0.08. And therefore this is 0.21. And therefore this is 0.14. Then we can kind of check it. What's 21 plus 8 plus 14 plus 57? 21 plus 8 plus 14 plus 57. 21 plus 8 plus 14 plus 57. 100%. Okay, so it all works out. So now I have my Venn diagram filled in. I got it broken down into mutually exclusive events so I can think about it and answer questions really easy. All right, first question. What percent of students got an A on both tests? Well, 8% got an A on both tests. What percent of kids got an A on the math test but didn't get an A on the physics test? What percent got an A on the math test but did not get an A on the physics test? 21%. And notice I've kind of given up on writing this in probability statements because I just don't need it. What would I do here? A on both tests, got an A in math and A in physics. And again, later on we're going to learn some stuff about ands. So even if we were to write these like this, it doesn't really help us calculating anything. This one here, let's just skip it. All right, we're at 13 minutes and 20 seconds. I think that's, we're so close to the end. Let's see if we can finish this up. Example, what you record matters as much as the random event. I'm going to stop. I'll just do this last example in the next video.